Holy smokes, this is our last topic of the year, and you know what that means? Sniff, sniff, this might be our last video this year. That makes me so sad. Actually, okay, that doesn't make me sad at all. Okay, anyway, so let's go ahead. Here we go. We're looking at weighted averages now. So whole milk is 4% butterfat. How much low-fat milk, which is 1% butterfat, should be added to 32 ounces of whole milk to result in a 2.5% butterfat mixture. All right, so what we need to do is we need to take the weighted whole milk and we need to add the weighted low fat milk, and that needs to give us the total 2.5% mixture. All right, so we talked about in class how when we do a weighted average, we don't just add the things together and divide by how many there are, because they might have different importances. Okay, so really the important thing here is how much fat, butterfat, is in the milk. And so what we're going to do is we're going to take 4%, which is 0.04, so that's the weight, and we're going to multiply by the amount of whole milk, which is 32 ounces. And then we're going to add the weight of the low fat, which is 0.01, and we're going to multiply by the amount of the low fat milk. And that should add together to give us a total weight of 0.025, because that's what we want this weight to be, and then it will be multiplied by the total amount of that. All right, and so the total amount should be 32 plus x. All right, and so this way we can see that we're taking the weights and multiplying it by the amount, and that should add up to give us the total. So let's pull out our handy dandy calculators, like my little handy dandy one here, and we will go 0.04 times 32, which gives me 1.28. So 1.28 plus 0.01x equals, we're going to distribute to both of those, so 0.025 times 32, which is 0.8, so 0.8 plus 0.025x. All right, just double checking. So now we need to move everything, so we're going to go minus 0.01x. So minus 0.01x, which will give us 1.28 equals 0.8 plus 0.015x. We'll subtract the 0.8 minus 0.8, and so that will give us, let's see, 0.48 equals 0.015x. Divide by the 0.015. See, this is just solving equations. Once you get past the initial setup, this is actually really easy. So we'll go 0.48 divided by 0.015, and we get 32. So x equals 32 ounces. And so that's how much low-fat milk we need. All right? So that was pretty easy. Well, let's look at another one. That was only 4 minutes. And I know I'm going to go over 5 minutes, but deal with it. Bill Gutierrez drove at a speed of 65 miles an hour on an expressway for 2 hours. He then drove for 1.5 hours at a speed of 45 miles per hour on a state highway. What was his average speed? Okay, so again, we need to take the weighted expressway. That would be a D, not an S. So the weighted expressway plus the weighted state highway, and that will give us the total average, or the total weighted average. Okay, so he was going 65 miles an hour on the expressway, and the rate of that is 2 hours. Now, you may recognize this. Time times rate equals distance. So this is actually giving you the distance that he traveled. And then plus, again, the weight on the state highway, well, it was only 1.5 hours. Now, those are the weights because that's causing it to change, right? We're only doing 45 miles an hour for 1.5 hours, so it shouldn't count as much as the 2 hours that you're doing 65 miles an hour. So that's how this applies to the weighted averages. Now, this should equal the total weight, which is the total number of hours, so that would be 3.5 hours. Sorry, not equals. 3.5 times the average speed. All right, so then you can figure it out. Again, please take notice that this is the time times the rate or the speed, which again gives us distance. So essentially on this side, we're adding up the distance. So we've got distance equals the time times the rate. Distance equals rate times time. So this is exactly what you've done before. It's just looking at it from another perspective. We're weighting those speeds based off of which one we spent more time on. Okay, so you add it together. We'll go 2 times 65, and then we'll add on 1.5 times 45, and so I got 197.5 equals 3.5 times the average, and so then we will divide by 3.5, and we get 56.4, and that was miles per hour equals the average speed because we divided by 3.5. So not too bad, huh? This is actually not too bad at all. And so this is our final answer. And please note that you could do this in 2 different ways. Like I said, you can either do the distance equals rate times time, get the total distance, and then divide by the time. Or you can think of this as being weighted averages, which is what I would encourage you to do for now. To take that value of 65 miles per hour and weight it, depending on how much time you spent doing that. And then take the speed of 45 miles an hour and weight it based off of how much time you spent doing that. And then it's the total time times the average speed, and that should end up giving you the final average. So there you go. That's 2 questions. Please watch the other video for 2 more.